Hi friends, welcome back to my YouTube channel Liang Crackers for cracking IIT and NEET. So today in this video we are going to discuss about a balancing equation, how to balance a redox reaction, right? So before going to discuss about this one, we must know three definitions. So what is redox reaction, what is disproportionation reaction, and what is conproportionation reaction. So redox reaction is a simple chemical reaction in which both oxidation and reduction would be occurred. And the next one, conproportionation, disproportionation. These two are under redox reaction, but specified character is there. So what is a disproportionation reaction? Disproportionation reaction means, of course, in this reaction also a redox reaction would be occurred, but a specific substance undergoes both oxidation and reduction reactions. Only one substance undergoes both oxidation and reduction reactions. Whereas conproportionation reaction is exactly reverse to the disproportionation reaction. It means two different substances undergo oxidation and reduction respectively to produce a one kind of substance. So it is exactly opposite or reverse to the disproportionation reaction. Okay. So just first, for example, redox reaction, one reaction you must know. So redox reaction. Suppose if we take N2 and by reacting with oxygen it produces 2NO. So in this, what is the oxidation state of nitrogen? 0. Here what is the oxidation state of oxygen? 0. And here more electronegative atom is oxygen, that's why it gets -2 charge. Automatically one nitrogen gets +2 charge. So nitrogen 0 to +2. What happened here? Removal of 2 electrons. So what is that? Oxidation. Here 0 to -2 oxygen, so adding 2 electrons. So what is this? Reduction reaction. So in a chemical reaction both oxidation as well as reduction reaction would be occurred, then the reaction is said to be redox reaction. Next one, disproportionation reaction. Disproportionation reaction. So here also under, this is also under redox reaction, but what is the condition, specific condition? Only one substance undergoes oxidation and reduction. But whereas here normal redox reaction, two individually, one undergoes oxidation, another one undergoes redox reaction. That is the difference. And now suppose if you take one example, decomposition of hydrogen peroxide. So is an example of disproportionation reaction. If you balance like this, whatever. So what is the oxidation state of here? Oxygen -1, only single oxygen atom. Here what is the oxidation state of oxygen atom? -2. Here what is the oxidation state of oxygen atom only, not molecule? So 0. -1 to -2 adding electron, -1 to 0 removal of electron. Only one substance undergoes oxidation as well as reduction. Then the reaction is said to be disproportionation reaction. And the opposite direction is a conproportionation reaction. Conproportionation reaction. So conproportionation reaction is nothing but what? Two individual substances undergo oxidation and reduction respectively to produce one kind of product. Suppose if we take Br minus by reacting with BrO3 minus to produce Br2 molecule. Here what is the oxidation state of bromium? -1. Here what is the oxidation state of bromium? +5. Here what is the oxidation state of bromium? 0. So -1 to 0, what happened? Removal of electrons, and +5 to 0 adding 5 electrons, whatever the number of electrons. So one undergoes oxidation, another one undergoes reduction, and respectively to produce one kind of product. So this is, of course, these three are example of redox reaction, but these two are having specific condition. Are you getting my point? So disproportionation reaction and conproportionation reaction. Now let's see what are the rules that we have to follow to balance a redox reaction. So points to be remembered, while balancing a redox reaction. First point, so we should write separate equations. Separate equation means one is oxidation, another one is a reduction reaction. We have to write separately. And the second point is balance. Second point is balance the number of atoms which oxidation number is changed. Which oxidation number is changed. So second point, what we have to do after write down the separate equation. So first focus on the atom which oxidation number is changed. Either same number of atoms are there or different number of atoms are there. If different number of atoms are there, we have to balance that first. And next third point, add proper number of electrons or proper electrons to the highest oxidation state site. To the highest oxidation state site. So fourth one, balance oxygen atoms by adding water molecules. Next, fifth point, balance hydrogen atoms by adding H plus ions. Now we have to do separate equations. These are all the four conditions, 1, 2, 3, 4. These four conditions we have to write separately in oxidation as well as reduction reaction. After doing like this, the last condition, balance number of electrons on both sides. Now 7, adding two equations. So we can get the medium acidic medium. So because we are adding balance the number of hydrogen atoms by adding H plus ions. So in the equation H plus ions would be there. Then what medium we have to use here? Indirectly, so acidic medium we can use it. Acidic medium. This indicates what? Acidic medium. After doing this one, if you want to convert into basic medium, I will do another shortcut simply. Okay. So remember, one more time I am repeating. So write separate equations of oxidation and reduction, right? And the second one, balance the number of atoms which oxidation number is changed. Which atom oxidation number is changed. Next, third one, add proper number of electrons to the highest oxidation side. So here we are balancing ions only. Here I will give you the explanation there. Ion balancing we are doing here only, not number of electrons balancing. Here last point, this point, balance the number of electrons is the exactly balancing number of electrons. But here we are not doing balancing number of electrons. We are doing only number of ions. From this one we can find whether it is oxidation reaction or reduction reaction. Let's see the explanation. Next one, balance the oxygen atoms by adding water molecules. Next point, balance the hydrogen atoms by adding H plus ions. From this one we can find the medium is acidic medium. And last one, balance the number of electrons on both sides. So by adding these two equations we can get the final balancing equation in acidic medium. So remember better this 7 points and I am wrapping. So we will discuss with an example. Okay. Right, we will see with an example. Suppose balancing permanganate ion by reacting with oxalate and produce Mn plus 2 plus carbon dioxide. Of course, question is about in acidic medium. Balance the redox reaction in acidic medium. Let's see. First, what we have to do? So we have to write the first point is what we have to write the separate equations. And here manganese, what is the oxidation state of manganese is +7. +7 to +2. +7 to +2. So what happened? Removal of electrons or adding electrons? So adding electrons, what is the process? Reduction. So first I am writing here, suppose here reduction reaction. Next here oxidation reaction. So separate, write down separately. Manganese MnO4 minus 2 Mn plus 2. So reduction reaction. Next one, oxalate ion to carbon dioxide. So first point is over. So we have to write the separate equation. The second point is what? Balance the number of atoms which oxidation number is changed. So manganese oxidation state is +7 here, +7 to +2 it converts, and number of atoms here plus only 1. Here also number of atoms 1. Already these two are balanced, so there is no need of balancing these two atoms, right? And the next one, so next point is what? Here what is the oxidation state of this one? X equals to, this manganese equals to +7. Now here X equals to +2. And one important point you should remember here. Of course, here only one atom is there, that's why we are writing X equals to something value. If two atoms are there and if we get some 2X equals to +10, then automatically X equals to +5 we should not write, because how many number of atoms are there we should maintain here. If it is 3 atoms are there, we should maintain here 3X, 4 atoms 4X, 5 atoms 5X. On both sides we should maintain the same number of atoms. We should not change. That is very, very important. Okay. So here only one atom is there. That's why I am writing directly X equals to +7 to X equals to +2. So X equals to +7 to X equals to +2. What happens here? +7 to +2. Adding electrons or removal of electrons? Adding electrons. How many electrons to be added actually? Normal concept. So here 7 electrons would be deficient and here 2 electrons would be deficient. So by adding 5 electrons we can get this equation. By adding 5 electrons, that's why we have to add 5 electrons to the more oxidation side. The third point is what? Add proper number of electrons to the side having more oxidation state. So 5 electrons to be added. Next one, balance. Next point is what? Balance the oxygen atoms by adding water molecules. Balance the oxygen atoms by adding water molecules. So left side only 4 oxygen atoms, right side there are no oxygen atoms. So we have to add how many water molecules? MnO4 minus 2 Mn plus 2. So how many water molecules? 4 oxygen atoms. So that's why we have to add 4 water molecule. Next, after that, balance hydrogen atoms by adding H plus ions. So balance hydrogen atoms. Left side there are no hydrogen atoms, and right side we have how many hydrogen atoms? 4 H2, 8 hydrogen atoms. So we have to add 8 H plus to the opposite direction. Now see, 4 oxygen atoms, 4 oxygen atoms, 8 hydrogen atoms, 8 hydrogen atoms. And don't think about the charge. We have to think at last, charge neutrality. This is not about charge neutrality. Yeah, we are doing ionic neutrality only. +7 to +7. So what happens? This is the third condition. By this condition, we can say whether it is oxidation reaction or reduction reaction. So what is the reaction here? By adding electrons is nothing but what? Reduction reaction. So after doing this one, so keep it separately, and this condition is over. Next, coming to this oxidation side. So which oxidation number is changing here? Carbon. If you think here carbon, 2x minus 8 equals to -2, then 2x equals to +6. 2x equals to +6 means each carbon atom having what is the oxidation state? +3. Here what is the oxidation state of carbon? +4. +3 to +4. Which oxidation number is changed? Carbon oxidation number is changed, right? So how many carbon atoms are there here? 2 carbon atoms. How many carbon atoms? Only 1. So we have to balance the number of atoms which oxidation number is changed. So here 2 atoms, that's why we have to multiply with this one, 2. Now after doing this one, how many carbon atoms? 2. Here also how many carbon atoms are? 2. So we should keep this 2x. We should not write x. 2x equals to something, then x equals to right. Because I told you already, if number of atoms are 4, we should keep here 4, 5, 5, 6, 6 like this. How many atoms are there? 2 atoms. So we should write only 2x. So 2x equals to, we got already +6. Now from this 1x, 1 carbon having +4 oxidation, then 2 carbon atoms are having, what is the oxidation? +8. So +6 to +8, what happened? 2 electrons are removed. By removal of 2 electrons, so we can get this balance. This is ionic balancing only, not electronic balance. Okay. After doing this one, now next condition is what? Balance the number of oxygen atoms by adding water molecules. So left side how many oxygen atoms? 4. Right side how many oxygen atoms? 4. Already these two are to be balanced. then there is no further addition of water molecule. If there is no further addition of water molecule, of course there is no further addition of H plus ions. So up to this point indirectly it is over. So this is the first equation, this is the second equation, right? So first equation, second equation. In first equation number of electrons are 5, in second equation number of electrons are 2. So we have to balance these two equations, I mean these two electrons, right? So here this is 2 and this is 5. So if first equation is multiplied by 2, then we can get what? So 16 H plus 10 electrons plus 2 MnO4 minus and giving 2 Mn plus 2 plus 8 H2O. So equation 1 into 2 we are getting how many electrons? 10. Here also if this equation is multiplied by 5, then we can get here also at right side 10 electrons, then 10 gets cancelled, so we are getting that resultant balancing equation. That's why second equation is multiplied by 5, then what is that? 5 oxalate and giving what? So 10 CO2 plus 10 electrons. Now after this 10 electrons get cancelled, and the resultant one 16H plus 2 MnO4 minus plus 5 oxalate ions and giving 2 Mn plus 2 plus 10 CO2 plus 8 H2O. This is our balancing equation for the given redox reaction. After doing this one, let's check charge neutrality, atom neutrality. So this is the left side, reaction side. So what is the total charge here? 16 plus means either positive or negative we have to calculate. So here 16 plus 16 charge, here only one atom minus 1, one compound or one substance minus 1, so 2 into means minus 2. Here each one oxalate having minus 2 charge, so 5 into minus 2 means minus 10. Let's see here what is the charge? Only manganese plus 2 charge, so 2 ions are there, that's why plus 4 charge. Here charge is 0, here is also charge is 0. So now plus 16 minus 12, what is the charge? Plus 4. Here also what is the charge? Plus 4. So this is nothing but charge neutrality. So first one is ion neutrality, the second one is what? Charge neutrality. After this one now, I mean just focus on the number of hydrogen and manganese or oxygen atoms. We have to cross check here. So number of hydrogen atoms, left side 16, right side also 16. Number of manganese atoms, left side 2 atoms, right side 2 atoms. Number of oxygen atoms, here 2 into 4 8 and 4 into 5 20. 28 oxygen atoms are present. And right side let's check, and 2 into 10 20, here 8 into 1 8, 28 oxygen atoms. So carbon, number of carbon atoms 5 to 10, and here of course 10 carbon. Everything is balanced. So that's why this is nothing but what? A balanced redox reaction. So we have to think like this and remember that 7 points, and you can do like this. And this is what is the medium. In the final equation we are getting 16H plus. In the final equation we are getting 16H plus. And if they are asking about basic medium, what we have to do? Simple trick. After doing this one, same number of OH would be added on both sides. So number of H plus ions, how many here? 16. So 16 number of H plus ions, that's why we have to add 16 OH minus ions on both sides. 16 OH minus ions on both sides. Now of course you know 1 H plus 1 OH minus giving 1 molecule of water. 1 molecule of water, that's why 16 H plus and 16 OH minus giving how many water molecules? So 16 water molecules. Left side 16, right side 8. So these 8 molecules, and from these 8 molecules get cancelled, so we are getting the resultant 8 molecules are left. And right side what we are getting here? 16 OH minus. So our equation is what? Now final equation basic medium from this 8H2O, and rest everything is same only, right? So this is get cancelled. Now here 2 Mn 2MnO4 plus 5 oxalate and giving, so here 2Mn plus 2 plus 10 CO2 plus from here these are get cancelled, now 16 OH minus is there. So now what is the medium from this equation? That is a basic medium. This equation is basic medium balancing equation and this equation is acidic medium balancing equation. So after this it's very easy to convert into basic medium. Whatever number of hydrogens are there, so the same number of hydroxy would be added on both sides. If we are getting the balancing 10H plus, add 10 OH minus on both sides. Only 8H plus, add 8 OH minus on both sides. Now plus and minus we can get the water molecule. So from two sides and cancel that water molecule, rest of the water molecules how many are present on which side we have to write. So this is regarding balancing a redox reaction, one example, and we will see with another example, then you may get it, right? Next, let's see another example. Redox reaction, balanced redox reaction between dichromate and oxalate. Dichromate and oxalate converts into chromic plus 3 plus same that CO2, and first we will see in acidic medium. After that you can convert into basic medium very easily, right? So first write the separate equations. Now whether it is oxidation or reaction, okay, whatever it is, and we are writing the same number of atoms, chromium, because the same type of atoms, chromium and chromium one side. Next one is oxalate one side, right? And first, second point is what? Balance the number of atoms, which oxidation number is changed. So chromium oxidation number is changed because here what is the value? 2x minus 14 equals to minus 2, then 2x equals to plus 12. Of course, one chromium atom having plus 6 oxidation, here what is the oxidation state? Plus 3. So plus 6 to plus 3 changes, but which oxidation number is changed to chromium? Here how many are there? Only 2 are there, here only 1 is there, so it should be multiplied by 2, and then we can get 2x equals to, we should keep it the same value, 2x equals to plus 12, here 2x equals to plus 6. So difference is how much? 6 electrons, and to be added to the higher oxidation side. So I'm adding directly 6 electrons plus Cr2O7 minus 2 to 2Cr plus 3. And next one is what? Balance the oxygen atoms by adding water molecules. So here only left side we have 7 oxygen atoms, so that's why add 7 water molecules. After this, balance the number of hydrogens. So 14 hydrogens are there and 14 H plus to be added to the left side, opposite direction of this water molecule. And this is our first equation, and here we got already this one is a 2x equals to plus 6, and from here 2x equals to plus 8, number of electrons difference is 2. After that already oxygen atoms are balanced, so directly you can write this is the second equation. First equation we have 6 electrons, in the second equation we have 2 electrons. If this equation is to be multiplied by 3, then we can get 6 electrons, so 6 electrons get cancelled each other. So this is the first equation, I am writing directly here, first equation, and second equation, second into 3, so 3 oxalate, 6 CO2 plus 6 electrons. Now the 6 electrons get cancelled, so 14 H plus 1 molecule of 2 dichromate plus 3 moles of oxalate and giving 2 moles of chromic ion plus 6 moles of carbon dioxide plus 7 H2O. So this is our balancing equation. After balancing this one, again compare. So what is the charge here? Plus 14, What is the charge here? -2. What is the charge here? -6. And here what is the charge? +6. This is 0. This is 0. Overall compound. So +6 at right side. Here +14 -8. Here also +6 at left side. So charge neutrality is over. And number of hydrogen atoms 14. 14. Number of oxygens here 7. Here 3, 4, 12, 19. So here already 6, 2, 12 and 7, 19 oxygen atoms. Carbon 6, carbon 6. Chromium 2 atoms, chromium 2 atoms. Everything is balanced. So this is our final balancing redox reaction for the given equation in which medium? Acidic medium. Again, if you want to convert into basic medium, just add same number of 14 OH minus on both sides, right? 14 OH minus on both sides, and this 14 H plus OH minus are forming 14 molecules of water. From here 7 get cancelled. So left side we have resulted in 7 water molecule and 1 mole of Cr2O7 minus 2 dichromate and plus 3 moles of oxalate. So giving 2 Cr plus 3 plus 6 CO2. This get cancelled already. So now resulted here rest is 14 OH minus is there. So what is the medium? It is the basic medium. Balancing equation basic medium, whereas it is the balancing equation in acidic medium. So this is about balancing a redox reaction, and we will see with polymolecule. If polymolecule is there, how to balance that redox reaction in the next video. Thank you.